Hello students, how are you? Okay, let's start the chapter electromagnetic induction. What do you mean by electromagnetic induction? It is the phenomenon of production of induced EMF and hence induced current due to a change of magnetic flux linked with a closed circuit. The term electromagnetic induction means inducing electricity by magnetism. Now, magnetic flux. What do you mean by magnetic flux? The number of magnetic lines of force crossing a surface normally is called magnetic flux linked with the surface. If the normal drawn to the surface area A makes angle theta with the field B, then the magnetic flux is phi equal to BA cos theta, and that will be vector B dot vector A. Magnetic flux is a scalar quantity. SI unit of magnetic flux is Weber. It is denoted by WB. It is the flux produced when a uniform magnetic field of 1 Tesla crosses normally an area of 1 meter square. The CGS unit of magnetic flux is Maxwell. 1 Weber equal to 10 to power 8 Maxwell. Now, I am going to explain you about Faraday's law of electromagnetic induction. What are Faraday's law? First law is whenever the magnetic flux linked with a closed circuit changes, when the magnetic flux linked with a closed circuit changes, an EMF, electromotive force, is induced in it, which lasts only so long as the change in the flux is taking place. Number 2 is second law. The magnitude of induced EMF is equal to the rate of change of magnetic flux linked with the closed circuit. Mathematically, epsilon equal to d phi upon dt. Now I am moving to Lenz's law. What is Lenz's law? It states that the direction of induced current is such that it opposes the cause which produces it, meaning that son opposes the father by which it has produced. In the similar way, it states that the direction of induced current is such that it opposes the cause which produces it. That is, it opposes the change in flux. It is produced by the change of flux, and after producing, it opposes the change of flux. Mathematical form of laws of electromagnetic induction. For a coil of one turn, induced EMF is given by epsilon equal to minus d phi upon dt, minus time phi 2 minus phi 1 upon t. For a coil of n turns, epsilon equal to minus n d phi upon dt, that will be equal to minus n phi 2 minus phi 1 upon t. The negative sign shows that induced EMF opposes the change in flux. It is in accordance with Lenz's law. Motional EMF. The EMF induced across the ends of a conductor due to its motion in a magnetic field is called motional EMF. It is produced due to the magnetic Lorentz force acting on the free electrons of the conductor. If a conductor of length L moves with the velocity v in a magnetic field B perpendicular to both its length and direction of the magnetic field, then the EMF induced across its ends is given by epsilon equal to BLV. Induced current I equal to epsilon upon R, and that will be BLV upon R. Force necessary to move the conductor. F equal to B square L square V upon R. Power dissipated as Joule heating loss. P equal to FV, and that will be B square L square V square upon R. Fleming's right hand rule. What is Fleming's right hand rule? It gives the direction of induced EMF. If we stretch the thumb, and the first two fingers of our right hand mutually perpendicular to each other, and if the forefinger points in the direction of the magnetic field, thumb in the direction of motion of the conductor, and the central finger points in the direction of current induced in the conductor. Relation between induced charge and change in magnetic flux. Relation between induced charge and change in magnetic flux. The induced charge flowing through a circuit depends on the net change in the magnetic flux linked with the circuit and is independent of the time interval of the flux change. Delta Q equal to delta phi upon R. That will be net change in the magnetic flux upon resistance. Methods of generating induced EMF. How will be generated induced EMF? As phi equal to BA cos theta. So the magnetic flux linked with a loop can be changed, and hence induced EMF can be produced by three methods. First method is by changing the flux field, magnetic field. Second is by changing the area of the loop, and third is by changing the relative orientation theta of the loop and the magnetic field. Motional EMF in a rotating coil. Motional EMF in a rotating coil. If an n turns of coil of area A is rotated with uniform angular velocity omega in a uniform magnetic field B about an axis perpendicular to the field B, then the motional EMF set up across the ends of the coil is given by epsilon equal to NBA omega sine omega t, and that will be epsilon 0 sine omega t, and it will be epsilon 0 sine 2 pi ft, where epsilon 0 is equal to NBA omega, and it is called peak value of the induced EMF. Both the direction and magnitude of the induced EMF change regularly with time. Both the direction and magnitude of the induced EMF change regularly with time. Such a simultaneously varying EMF is called alternating EMF.